Have you ever really stopped and wondered how an AI, something that's just a bunch of connections and math, can generate something that actually feels meaningful? Well, today, we're going to break that down. We're going to go on a journey from a simple web of wires to that incredible moment where a machine seems to actually understand. Let's dive in.
And yeah, this is really the whole mystery, isn't it? I mean, it's one thing to talk about algorithms and network weights all day, but that doesn't explain the leap into actual coherence, into something a person can really use. So how does it happen? We've got to start at the very, very beginning.
To really get this, we have to rewind the clock all the way back to square one. We need to look at an AI before it's learned anything at all. We're talking about its initial state, a world completely empty of meaning.
So when a neural network is first born, it's basically just this, a giant neutral graph. Think of it like a massive web with millions of potential paths. Sure, the nodes are connected, but the weights, the things that decide how much influence one node has on another, they're totally neutral. And the biases, which are kind of like the network's gut feelings, are all set to zero. It doesn't know a thing yet. It just has the raw potential to learn.
A really great way to picture this is to think of a blank city map. All the roads have been drawn, connecting everything to everything else. But there's no traffic. There are no famous landmarks, no popular restaurants, no good routes or bad neighborhoods. The structure's there, but it has absolutely no purpose. Yet?
Okay, so how do we get some cars on those roads? That brings us to the first huge step, training. This is the process where we take that big neutral graph and we start teaching it to actually care about certain things over others.
So during training, you just feed the network a ridiculous amount of data, millions and millions of examples. And with every single example, tiny little adjustments happen. Some connections get stronger, some get weaker, the biases start to shift, and the network starts to form expectations. Over time, that graph isn't neutral anymore. It starts to develop superhighways for common ideas and little dirt roads for others. It's going from just raw connectivity to what we call weighted relevance.
And this gets us to the really crucial role of biases. A bias is just the graph learning to lean in a certain direction. It's the system developing a tendency, kind of like a gut feeling that says, hey, this idea seems to come up a lot, so I should probably pay attention to it. That little lean, that's the very first hint of interpretation.
Right, so get this. In this context, bias isn't a bug, it's a feature. It's absolutely essential. Without it, everything is equally possible, nothing stands out, and meaning just can't happen. But with bias, certain ideas start to matter by default, and that's when the graph can finally start making sense of things.
But let's pump the brakes for a second. We've got to be super clear here. What we have so far isn't true understanding. Not really. It's just a very, very sophisticated kind of statistical memory. The graph knows what patterns are common, but the biggest leap, that's still to come.
So, if it's all just statistical memory, how in the world does it give you an actual answer? Well, this is the really cool part. This is the moment where a human being, you, walks in and changes the entire game just by asking a question.
And this is the key thing to get. When you type a question into an LLM, you are not doing a Google search. You're not looking up a file. What you're actually doing is creating a perturbation. You're disturbing the entire graph. Your words are like a stone dropped into a perfectly still pond, sending ripples everywhere at once.
This is a completely different way of thinking compared to old-school computers. Your laptop finds a file that already exists. It's static. A neural network performs a dynamic reconstruction. It builds a new answer from the ground up, just for you, in that exact moment, based on that specific context.
So here's exactly how an answer is born. First, your question perturbs the graph. Second, that energy propagates, zipping through the whole network, lighting up some paths and dimming others. And then comes the most critical step of all. The graph settles. Think of it like a guitar string that's been plucked. After all the wild vibrations, it finds one clear, stable note. That final coherent pattern, that's the answer. The very last step is just translating that mathematical shape into words we can actually read.
So let's zoom out. What's the big deal here? Why does any of this matter? Well, when you understand this process, you realize we're not just looking at a faster calculator. This is a fundamentally new kind of tool, and it's changing our relationship with information itself.
Let's just put it side by side. In a classical system, information is like a book on a shelf. It's static, it lives at one address, and we are the ones who give it meaning. In an LLM system, information is more like a conversation. It's dynamic, it's totally context-sensitive, and the meaning,
Well, the meaning just emerges from the relationships in the graph itself.
It's like there's this incredible, invisible translation going on. On the inside, in the machine's world, it's all just pure geometry. Meaning is a shape. A relationship is just a distance. Importance is simply the magnitude of a signal. But then, on the outside, it speaks our language. That shape becomes an explanation, that distance becomes a narrative, that magnitude becomes emphasis. The intelligence we see is happening right there at that boundary.
And this is why that whole debate about whether machines understand might be asking the wrong question. It's probably more useful to think of it like this. LLMs don't contain meaning the way a book contains words. They enact meaning. It's a process they perform. It's an action, not a possession.
And the wildest part, the reason this can feel so natural, so eerily familiar, is because it kind of mirrors how our own minds work. You don't just retrieve a memory perfectly like a computer file. You reconstruct it, right? Your brain is also just a giant, messy, biased, weighted graph. So it feels familiar because even though it's not the same hardware, it's running on the same fundamental logic of
All right, so let's run through the whole story one last time. Super quick. A graph starts by just recording relationships. Training teaches it which ones actually matter. Biases give it some expectations. Then, your query sends a ripple through the whole thing. The graph settles into a stable, coherent pattern. And finally, that pattern gets translated into language you can use. That's the whole journey, right there, from simple wires to complex meaning.
And that leaves us with this one last pretty mind-bending thought to chew on. If understanding isn't a thing that you have, but a process that you perform, then what we're witnessing here isn't machines becoming sentient. Maybe we're just watching them learn how to join us in that performance. Makes you think, doesn't it?